Hello, students. We are into 7.2 MCs. Okay, oops. I think I jumped a little bit here. There were some at the bottom. Let's take a look. You have 1, 6, and then 13 through 16 and 18. So that's not that many. So how much greater is 0.76 times 3 than 0.75 times 3? How can you tell without multiplying each product? The idea here is to remember your good friend, the distributive property. If you can kind of remember that when you see problems like this, you can say, well, 0.76, why that is 0.75 plus 0.01, because that's what it is. And that way, if you're multiplying by, let's say, 4, you know 4 is going to multiply to both of those. And 4 times 0.75, well, that's that value that you get from the other one. And so really, I could tell that I'm off by 0.04 right away. Okay. All right. Let's see here. Yeah, so that's that takes care of that piece. Let's see here. 1, then 6 is the product of two positive decimals, each less than 1. Is it always less than each of the decimals? Justify your answer. Okay. So this is a great question. Two positive decimals, each is less than 1. So pick two decimals if you want to kind of get an idea for it, but then try to say, hey, this I think is always true. And if it's always true, we should have a reason for it. Okay. There we go. There's 1 and 6. And lastly, sorry about that. Little puppy's barking at something. Behave yourself. All right, let's see, where are we? 13 through 16, so we'll jump to the next page. 13 through 16. So you have these problems. Now, these are pretty common ones from students in class. So you've got Jamal wants to know why 0.3 and 0.30 are equal. Like one looks bigger than the other. Fred says to multiply 32.7 times 2.6, he just multiplies 327 by 26. And because 33 times 3 equals 99, he just records it as 85.02. So again, this is thinking about how do I know where my answer should be, using estimation maybe. Let's see here. In multiplying 0.125 times 0.08, Roger knew the rule says he should multiply 125 times 8, then move the decimal point 5 places. When he did the calculation on the calculator, he saw the answer was 0.01, and he was really confused because the rule doesn't seem to be working, right? If the rule worked, he should have 5 decimal places, but the calculator said he only has 2. How do you help this student? How do you help Roger? I don't know why, for some reason, when it said help Roger, I'm thinking Uncle Roger. My wife sent me like this TikTok of this guy who like critiques other food, and it was like Uncle Roger. Anyway, that's what goes through my mind. Let's take a look. So we've got a student multiplies 6.5 times 8.5, uses this approach, gets 55.25. Comes down here, does 8.5 times 6.5, multiplies. Okay, so let's see here. Looks like multiplied. Oh yeah, the 1/2 times the times the 8.5, then multiplies 6 by it, gets these numbers, adds them together, and says, hey, wait a minute. Those aren't the same. What happened? What happened here? What's wrong? What isn't wrong? What went well? What did this student do correctly? Let's see here. Yeah, I didn't assign 17 and 18. I think I have in the past. I know I've assigned 18 in the past because these are two numbers that on a calculator, when you put them in the calculator, they appear to be equal, but that you should know that these are not equal. And there are ways to tell that one is bigger than the other, which one's bigger, even though your calculator may not be able to handle that. And I think that's what's going on there. I probably should have assigned 19, but I didn't. Yeah, so I think this one is 7.5 plus 2.8, and students add them together, keeping the decimal point lined up, and they get 9.13. Like, what happened? Get the mistake. So that'll probably, this one's not a bad one for like a test. I'll probably have to think about that. Let's see here. Several students were asked to add 1/10 and 0.1. Add 1/10 and 0.1 together. And here were the answers that were submitted. For each response, write a decimal number. This would have been a good one too. What's wrong with me? Why didn't I assign additional? I probably should have. All right. So let's see here. Yep. Several different answers submitted here. Describe and correct Amy's error in the solution. Oh, gotta love error correction. And Bella knows to move the decimal point by counting the number of digits, turns the following problem. So she multiplies, knows 2 digits, so she gets this answer, 2.24. Is she correct? What is the danger of teaching this method? And how did it work? So yeah, I mean, you could go through and kind of check and see how that worked for the student. And again, this this is where sometimes things get a little bit crazy when you're doing multiplication with this. If you're trying to take a different approach, there really is nothing technically wrong with this approach at all, starting with multiplying by the 5 and getting here 160. But when you do 2 times 2, in their mind, you're thinking 4, so they're golden. But then they write the 4 like in the ones place, right? But really, when you look at it, if we were tracking our decimal places, this would actually be in the tenths place. So it should be moved in one place value. And if you put a 0 here, that 0 is not, it's not like a placeholder. It's actually representing how many hundredths you would have in that. And you should have 0 hundredths when you multiply ones by tenths. So very similar to what we've done in the past. And the mistakes that are made with decimals are the same as the mistakes that are made with whole numbers. I think that's the big piece to remember as you go through these questions and go through these problems, is really saying, hey, the multiplication mistakes that involve place value may have nothing to do with decimals. They may still be the same mistakes a student had when you were multiplying whole numbers back in chapter 3. So that's why the firm foundation is huge. It's also why it's so important depending on which grade level you end up teaching. You may be thinking, hey, I want to do second or third grade. You may end up teaching fourth or fifth grade. And what you're realizing is the thing you're trying to build on, the foundation, may not be solid. And you will have to kind of come back and say, hey, I've got to give you some pieces. I noticed the mistakes you're making. They seem to be from a prior course, prior grade level. And so you have to be able to say, well, let's build those up so we understand the concept. And that's why we don't teach college level class to prepare you to teach third grade. It's K through 8 in terms of math content. You might be certified only all the way up to 6th grade, typically, probably, depending on which. I think they just said they're coming up with a new certificate too. That might be transitional kindergarten up to 3rd grade, but that one's not out all the way yet. And so if you do go TK through 3, then perhaps the math content you need may be only going up through 6th grade. But if you're getting the standard certification to allow you to teach things like 4th grade, which really does, I mean, honestly, it makes you more marketable. I hope you'll consider it. Like having something that says you can do more is never usually a bad thing. And if your depth of knowledge is solid enough, you might even become a math specialist for one of the schools. So keep that in mind as you go forward. If you have other questions, let me know. Otherwise, off you go.